Hello everyone, I am Aishwarya, Assistant Professor of Computer Application from SFR College for Women, Sivakasi. Today I am going to talk about the network layer design issues. These are our learning objectives. First one is what is network layer design issues. Second one, store and forward packet switching, services provided to the transport layer, implementation of connectionless service, implementation of connection oriented service, comparison of virtual circuit and datagram networks. Now, what is network layer? The network layer is the third layer of the OSI model, which handles the service request from the transport layer and forward the service request to the data link layer. It translates the logical addresses into the physical addresses, which determines the route from the source to the destination and also manages the traffic problems such as switching, routing, and controls the congestion of data packets. Next, network layer design issues, which is mainly focused on getting packets from the source to the destination, routing, error handling, and congestion controls. In this session, some issues include the service provided to the transport layer and the internal design of the network. First issue, store and forward packet switching. The host sends the packet to the nearest router, but this packet is stored there until it has fully arrived. Once the link is fully processed by verifying the checksum, then it forward to the next router until it reaches the destination. This mechanism is called store and forward packet switching. Here, this is our diagram for environment of the network layer protocols. Here, the major components of the network are the ISP's equipment, which is a router connected by the transmission lines, which shown inside the shaded oval, and the customer's equipment, which is shown outside the oval. Host H1 is directly connected to the one of the ISP's router A, perhaps as a home computer that is plugged into the DSL modem. H2 is on a LAN, which might be an office Ethernet with the router F, which owned and operated by the customer. This route has a leaked line to the ISP's equipment. Here F shown outside the oval because it does not belong to the ISP. Router on the customer are considered as part of the ISP's network because they run the same algorithm as the ISP's router. Next issue, services provided to the transport layer. The network layer provides services to the transport layer at network or transport layer interfaces. These providing services need to be designed with the following goals. The services should be independent of the router technology. The transport layer should be shielded from the number, type, and topology of the routers present. The network addresses for the made to the transport layer should use a uniform numbering plan even across LANs and WANs. Based on the services, there are two types of connections provided. Connectionless, the routing and injection of the packets into the network is done individually. There is no needed for the setup. Connection oriented networks must offer reliable service and all the packets must be transmitted over a single route. Next issue, implementation of connectionless service. Packets, if connectionless service is offered, packets are injected into the network individually and routed independently of each other. Here the packets are also called as datagrams and the network is also called as datagram network. If the connection oriented service is used, a path from the source router all the way to the destination router must be established before any data packets can be sent. This connection is called a virtual circuit with a physical circuit set up by the telephone system, and the network is called virtual circuit network. Here this is our diagram for routing within a datagram network. The process P1 has a long message for P2. It hands the messages to the transport layer with instructions to deliver it to the process P2 on the host H2. The transport layer code runs on H1 within the operating system. The network layer has 4 packets 1, 2, 3, 4 and send each of them in turn to router A using some point-to-point protocol. At A, the packets 1, 2, 3 arrived on the incoming link and had their checksums verified. Packet 1 is then forwarded to E and then to F. When it gets to the F, it is sent within a frame over the LAN to H2 host. Packet 2 and 3 follow the same route, but A decided to send packet 4 via a different route than that of the first 3 packets because of the routing traffic jam. The algorithm manages the table and makes the routing decision is called the routing algorithm. Next issue, implementation of connection oriented services. The connection is established here. Routing from the source machine to the destination machine is chosen as the part of the connection setup and stored in tables inside the routers, that the route is used for all traffic flowing over the connection. When the connection is released, virtual circuit will be terminated. The best example for this is telephone lines. In connection oriented services, the data packets are delivered to the receiver in order in which they have been sent by the sender. It can be done in 2 ways. Circuit switched connection, a physical path or a circuit is established between the communicating nodes and the data stream is transferred. Virtual circuit switched connection, the datagram is transferred over a packet switched network in a way that that it is schemed to the user, that there is a dedicated path from the sender to the receiver. The virtual path is established here. The other connections may be using the same path. Here the diagram for routing within a virtual circuit network. Here the host H1 has established connection 1 with host H2. This connection is remembered as the first entry in each of the routing tables. The first line of the A's table says that if a packet having connection identifier 1 comes from the H1, it is to be sent to the router C and given connection identifier 1. Similarly, the first entry at C routes the packet to E, also with connection identifier 1. H3 wants to establish a connection to H2 and it chooses connection identifier 1. This process is called label switching. A good example of connection oriented network service is multi-protocol label switching. Here the next issue, here the major issues are listed here. First issue, circuit setup. In datagram network is no need for that. In virtual circuit network is needed for that. Addressing issue. In datagram network, each packet contains the full source and destination address. In virtual circuit, each packet contains a short virtual circuit number. State information issue. In datagram, routers do not hold state information about the connection. In virtual circuit network, each virtual circuit requires router table space per connection. Routing issue. In datagram network, each packet is routed independently. In virtual circuit network, router chosen when virtual circuit is set up, then all the packets follow it. Effect of router failure. In datagram network is none except for packets lost during the crash. In virtual circuit network, all virtual circuits that passed through the failed router are terminated. Quality of service issue. In datagram network is very difficult. In virtual circuit it is easy if enough resources can be allocated in advance for each virtual circuit. Conjunction control issues. In datagram subset is very difficult. In virtual circuit subnet is very easy if enough resources can be allocated in advance for each virtual circuit. Thank you for watching this video. I hope you all get a good clearance about the concept of network layer design issues. If you want more video like this, click the link. Thank you.